Hi, and welcome to the solution for the fourth circuit. We're given an 8-volt battery and 3 resistors. Let's talk about the resistors in parallel. There are 2 resistors in parallel. There is a 100 ohm resistor, R2, in parallel with a 60 ohm resistor, R3. Those 2 resistors together, as counted as one, are in series with R1, which is also in series with the battery. So there are 3 things in series here: the battery, R1, and this chunk of R2 and R3. We're asked to analyze the circuit. So the first thing we need to figure out is what is the current coming out of the battery. That will be the voltage in the battery, which is 8 volts, divided by the total resistance of the circuit. So now we have to figure out what the resistance in the whole circuit is. So the resistance in the whole circuit is the resistance of R1 in series with the chunk of R2 and R3, and R2 and R3 are in parallel with each other. So I write it this way: R equivalent equals R1 plus, because in series you add the resistances together, plus this chunk, which is R2 to the negative 1 power, plus R3 to the negative 1 power, and then raise that chunk to the negative 1 power. So this piece right here is the one parallel piece that we're treating as one resistor in series with R1 and in series with the battery. Now with numbers, 12.5 ohms plus 100 ohms to the negative 1 power plus 60 ohms raised to the negative 1 power, raise the whole thing to the negative 1 power. Let's rewrite. Okay, so let's do 100 raised to the negative 1, 0.01. Okay, 60 to the negative 1 power, 0.01, and then 6 repeating. Let's add these together. So 60 to the negative 1 plus 100 to the negative 1, 0.02, and then 6 repeating. And let's raise this answer to the negative 1 power. That's a resistance of 37.5 ohms. So together, the 100 and the 60 give 2 options for the current, so the resistance is actually lower because there are 2 options for the current, and the resistance becomes 37.5. I add these together, 12.5 plus 37.5, I should get 50. So the total resistance is 50 ohms. So now we can figure out what the current in the battery is. 8 volts divided by 50 ohms. .16 amps. So coming out of the battery, let's draw. .16 amps of current. Well, it doesn't have a choice before it reaches the 12.5. So I know that I have that same current running through the 12.5. 0.16 amps, 0.16 amps. And that means I could figure out what the voltage drop is in that resistor. So let's do that now. We'll color that in orange. So we'll say V1, which is the voltage drop on resistor 1, will equal I1 times R1. So that's 0.16 amps times 12.5 ohms. That is a voltage drop of 2 volts. Okay, so I know that 2 volts voltage drop at that point. Okay, so that current is going to continue until this split. And then the current is going to split 2 ways. And the 2 ways will have to add up to 0.16. But I don't know what those currents are yet. And they don't split evenly because I have a 100 ohm and a 60 ohm resistor that are not the same. That means I have to start thinking about the voltage drop. So let's pick a point on our circuit. The first thing I encounter is the battery. It gives me +8 volts. Then I encounter resistor R1. Let's make this clearer. +8 volts. This would be R1. We just figured out that that voltage is a -2, a drop of 2 volts. And then there's going to be another drop to get us back to where we started. We have 2 choices, but either way, we have to drop by the remaining amount of voltage. And that remaining amount is 6 volts. Because we have to end with the same voltage. That means that the voltage drop V2 in the 100 ohm resistor is 6 volts. It also means that V3, the voltage drop across the 60 ohm resistor, is 6 volts. So I can figure out that I2 is equal to 6 volts divided by 100 ohms. 6 divided by 100 is 0.06. And the current flowing through resistor 3 would be 6 volts divided by 60 ohms, 0.1. If you added 0.1 and 0.06, you get the current 0.16. So that when they combine again, whoops, when these 2 currents combine again, .06 amps and 0.10 amps, they combine to be 0.16 amps, which is what we started with. So that 0.16 amps of current is going to flow into the battery. Okay. Hope this was helpful. Have a good day.